further ado, I'm going to turn it over to Pontus, who's going to begin with the science topic introduction. Thank you, Pontus.
Well, thank you, Michael. All right. So as Michael said, we are today going to launch into, we call it sort of science topics, but really this is the nitty-gritty of the measurements. And I hope you all had a good day yesterday. And so I will be the moderator for today. And then after we've gone through all of these measurement types and topics from the working group leads, as you will see, Merav Ofer will have an invited presentation, as you can see in the agenda. I'm going to be pretty adamant on the times today because except for the charged particle presentation, which is 40 minutes, the rest of them are 20 minutes long only. So if there's no time for questions and answers during those short presentations, please save them until the questions and answer session at 2:10 p.m. after the group photo, and I believe that will be in the same room as you'll get an email about. Okay, so I only have maybe 10 or 15 minutes worth of introduction and setting the stage here. This is the current organization, or the organization we've had over the past 4 years. And what you will hear today is basically the box on the very right here from all the topical group leads that will each go through their science topics and measurements. And I got to make a shout out here because these ladies and gentlemen, they have really spent a lot of their own free time on making sure that we have not only the compelling science, but also feasible instrumentation for all of this. And I know we've asked you to do this many times before, and a lot of you feel that, well, we're just repeating this same presentations over again at the same workshops and even other meetings. But that's really part of the hard work that we do here in terms of repeating the message and repeating the message. And of course, we've done this also for the Interstellar Probe mission now for probably 100 presentations or so. But all of this really, really counts. And what can I say? Thank you. I mean, this is all that we're excited about together in this team. Okay. So today I'm going to show this again here. It's the middle column here that we're looking at today, basically the measurement types and measurement requirements. Yesterday evening, when I looked at this again, I went, oh my God, I looked at one column in here and one column on the very left here. I apologize, it's completely empty. And I was going to put Jamie on the spot, but he actually pointed this out early this morning. So obviously this is a typo and we will correct this column as soon as we get to it. A little bit about the way we thought about this. Alice will show this more tomorrow, of course. But in terms of mass allocation that I already talked about yesterday, I would like you to think about this as a not instruments per se verbatim as we have here in the heritage on the left, but basically what this example instrumentation has guided us to is to put sort of reasonable mass and power allocations in there. So I would like you to think about this as mass allocations, and of course in the future, this is what the science community will have to fill with appropriate instrumentation. And I think it's fair to say also a lot of the instrumentation that you'll see here in terms of just example instrumentation, it needs a lot more optimization because listen, we have this Interstellar Probe mission, we've never been out there. So needless to say, the exact instrumentation that will fly in the future may not exist in an optimized fashion. But having said that, we've come to the conclusion early on, actually, that there's not really any new technology that needs to be invented for the instruments here, but this is rather about optimizing already existing instrument technologies. Next, accommodation. This is a little pitch for what Alice will also show in more detail tomorrow. A lot of thinking has gone into where we actually want to put this instrumentation in terms of accommodation on the spacecraft. So Alice will bring this into more detail, and I think also the leads here today will also share some of the thinking that went into the accommodation requirements and the requirements toward the spacecraft, for that matter. Okay, so these are the groups of instruments that you will see. And again, as I said yesterday, the intent here is not to show instrumentation that will do everything that we ever dreamed about. But this is sort of the example payload that could fly within a realistic mass allocation. I already went through that yesterday. So I also would like you to pay attention to the important trades that we need to highlight here, because once you have a fixed mass allocation, there will be very important trades and decision for a future STD. And for example, I'm going to just quickly go through some of the very highlights to sort of guide you on what you should listen to here. For example, Drew is going to talk about charged particle instrumentation here, and a lot of discussion has gone into the plasma subsystem. Of course, we all know, the physicists among us, that plasma measurements are extremely important, not only in the helium sheath, but also once you get into the interstellar medium. So one of the big trades here is composition versus geometrical factor, and Drew will talk more about that in detail. The other one is, of course, the pickup ion instrument. And here it's not only pickup ions in the solar wind, but it's also the plasma composition and the non-thermal composition of the interstellar medium once you get out there. So that sort of trickles back up to, well, you need an instrument that can both cover the solar wind pickup ions and also the interstellar RAM direction. So listen more to that as well. The other one is ENAs. If you paid attention to the mass allocations, ENA has a smaller percentage mass allocation than the charged particles. As I said from the outset, we do sort of prioritize in situ measurements in a mission like this, and I think that's natural. So here within this mass allocation, the energy range versus mass, and basically how do you cover an IMAP high or IBEX high type of instrument and an IMAP ultra type of instrument in one mass allocation. The other one is the plasma wave measurements. A very natural one here is, of course, the length and diameter ratio of the antennas versus the performance. And a lot of thinking and simulations have gone into that, and I would like you to pay attention to also what Stuart has to say about that. There one more here. Almost forgot. So Andre will also talk about the in situ neutral measurements. Very obvious trade here is how do you also resolve the flow direction of interstellar neutrals, and how do you do that within a reasonable mass allocation? So again, pay attention also to what Andre has to say about that. There obviously a lot of detail levels of trades in all of these discussions, but I think I will stop here. And if there are any questions, I can take them now. Otherwise, I would like you to encourage you to save those questions until the talks. And so let me just pause here for a quick moment and see if there's any burning questions. We have one question. And this is from Marshall Eubanks. If the questions are being answered at the end of the entire string of talks, can we just ask them here in real time and have the session chairs manage which gets answered at the end? That's a very good logistical question. I think so let me ask let me ask Andrea here. All these questions will remain in the Q&As, and we're under no risk of losing them. Correct, Andrea?
That's correct. And what I could do as we go through the sessions is gather the questions as Marshall suggested, and just have them available for the open discussion session. So I can do that.
Okay, so this is a very good suggestion, Marshall. So let's do like that, so that we don't run any risk of forgetting any questions. So please post your questions in Q&As. If we can't answer them during the talks, we'll just answer them in the Q&A session, which will be in a different room, correct, Michael?
Yes, that'll be the afternoon session. That'll be the afternoon session.
Yep, so Andrea will collect the questions and bring them over physically to that other room.
And the full schedule for that is online at the website. To answer Stuart's question, which just popped up, I just had it up in front of me. We're beginning the discussion period at 2:10 p.m. today. At 2:10 p.m. Okay.
And the group photo will be at 2:10 at that same time, right? We'll begin with that.
Yeah, essentially, yes.
Okay.
Yep.
Okay, sounds good. If no other burning questions, why don't everybody go back and grab a second cup of coffee and get ready for a very exciting day.
All right. Thanks, Pontus.
Okay.
And everybody will be back here at 10:30 to begin Drew Turner's talk on particles. And look forward to seeing you back here.